All right, guys, so in our final section for our unit on significance tests, we're going to talk about how to use paired data. So for their second semester project in honor statistics, Libby and Catherine decided to investigate which line was faster in the supermarket than the express lane or the regular lane. To collect their data, they randomly selected 15 times during the week, went to the same store, bought the same item. However, one of them used the express lane and the other used a regular lane. To decide which lane each of them would use, they flipped a coin. If it was heads, Libby used the express lane and Catherine used the regular lane. They entered their randomly assigned lanes at the same time, and each recorded the time in seconds it took to complete the transaction. We're going to carry out a test to see if there is convincing evidence that the express lane is in fact faster. So we've got all of our data here in this table. Let's go ahead and start our 4-step process with our statement. So first of all, we're going to have to be a lot more specific on our parameter of interest. Mu is going to represent the true difference, and then we have to say which direction we are testing. We can pick one or the other. I'm going to take the express lane minus the regular lane for my particular difference. So the true difference in time that it takes to check out. So let's think about what our hypotheses are going to be. For our null hypothesis, we're going to say that there is no difference. In other words, that the mean difference is 0. Now, for our alternative hypothesis, if we're taking express minus regular, and what we expect to happen is for the express lane to be quicker, that means the express lane is going to have smaller times than the regular lane. So if I take express minus regular, that would be a smaller number minus bigger number, which if I think about, is that going to be a positive or a negative number? Well, smaller number minus bigger number should be a negative number. In other words, I'm expecting for our alternative hypothesis that the mean is going to be less than 0. If you were to take regular minus express and flip that, then obviously our alternative would also be flipped. Now our mean would have to be greater than 0. So our significance level is the last thing we need to include up in our statement. So since it doesn't tell us what to use, we'll assume 0.05. All right, let's go ahead and set up our plan next. So for our plan, we are going to be doing a t-test. So checking through our conditions, it does say that it was random, so we are good there. Next, there were 15 times during the week that they went, so 15 times 10 is 150. Is it reasonable to assume they could have gone more than 150 times? And yes, that is a reasonable assumption to make. Last but not least, for our central limit theorem, 15 unfortunately is not greater than or equal to 30. So in checking the graph of the difference between the two, there are no outliers, no major skew. So we are going to proceed with caution onto our do step. So in our do step, hopefully you've already got this data into your calculator. If not, there is another video to show you how to do that. But the time for the express lane is list 1. The time for the regular lane is list 2. If we take list 1 minus list 2, I went ahead and put that data into list 3. That is now the data that I'm using for my t-test. So in my t-test menu, I'm choosing data as my option. I'm picking list 3 and filling in the rest of the information. Once we've done that, here is what we are coming up with. Our test statistic t is negative 1.97. Our p-value that our calculator is giving to us should be 0.03. And last but not least, let's also include our degrees of freedom, which is 1 less than our sample size. 15 minus 1 is 14. So keep in mind sample size because we're looking at a combined difference, and there are still only 15 points of data, not 30. So let's go ahead and write our conclusion in context now. We are going to say that because our p-value of 0.03 is less than our significance level of 0.05, we would reject our null hypothesis. In other words, there is convincing evidence that the express lane is quicker. Now, while we are able to do that, while the p-value is in fact less than the significance level, we have to be kind of careful. In this case, that p-value of 0.03 is fairly close to 0.05. And if we really look at it, the difference really is not all that great. It's not all that quicker most of the time to take the express lane. So that brings up the idea of kind of the difference here between what we call statistical significance and practical significance. So statistical significance is simply that you have enough supporting evidence to reject your null hypothesis. In other words, here we had statistical significance. Our p-value was less than our significance level alpha. So we had enough to say that it was statistically significant. However, being statistically significant does not necessarily mean practically significant. So practical significance is viewing a problem with a real life or practical mindset in order to discern or decide whether statistical significance truly applies. In other words, looking at it from a lens of, does this actually matter? Is this result actually important? Not just, can I reject the null hypothesis, but is it going to be meaningful if I do? That is the difference between statistical significance and practical significance. Until next time, have a good rest of your day.